Hey, hi everyone. Welcome to the first video of the series Understanding Model Context Protocol, the Concepts and Architecture. In this video, we will primarily focus on the theory part of MCP. Basically, we will go very detailed about how MCP works. Like it has many important concepts like tools, resources, prompts, different protocols like stdio, HTTP, and many more. So that's what this in this video we will lay the foundation and we will clear all the theoretical concepts of MCP. So please pay attention to this video, especially because this will the main foundation for entire series. Okay, so with that, let's start. Just to give you some context, already we had discussed in the intro. So what is an agent? So an agent is able to think, they can plan, and then ultimately they take action. So in order to take action, you might encounter three different terminologies like something called tools, MCP server, and agent skills. Tools are nothing but custom functions that you have written and you are giving that tools or that functions to your agent, so that your agent can call those functions and take some action on your behalf. Now MCP server is something where what you are doing, you are connecting your agent to an external MCP server. That means some people have developed some set of tools and they are hosting it in the form of a server, and basically you are connecting your agent to that server. So now your agent is now more powerful to use that MCP server. So now we can use those tools developed by some people. So tools is something that you have written. MCP is something like you can connect to someone's tools, that way. And third is the agent skills. So basically this is more of guideline kind of thing. Basically you have documented what kind of skills an agent can follow, and agent will follow through that skills or document while taking the action. So with these three component, the tools, the MCP, and the skills, agent becomes more powerful. With tools you get this much power, with MCP your agent becomes more powerful, and with skills agent become foolproof, you can say. So this way these three are a very essential part of an agent action group. Okay, so before going into MCP, so let's just see, like when I say like MCP server hosted by some people, where does it is hosted? So let's see that. So if you search in Google MCP, you will land on this page, and like the MCP protocol like that. And so you go to this community, and if you scroll down, you will see the example servers. And at the end, you will see some link to MCP server repository. So this is a GitHub repository for all the MCP server hosted. Okay, so if you go over here on the top, you will see that there are different programming language supports are there. That means we can write this MCP using C++, Go, Java, PHP, Python, like that. So for example, if we want to write MCP server using Python, we'll have to use this Python MCP SDK. We have to use to write the MCP server. Okay, and so this server just reference servers. These are to demonstrate MCP capability. So that's what these are given. Some of the interesting one are the file system and time. I will be also using these two to just explain you how does MCP works. This is more for demonstration purpose. And then you will see some list of official integration. So these are the MCP servers that are maintained by the companies building production ready MCP servers for their platform. So basically you can trust these MCP servers. So for example, you can see MCP servers from, I can just Alibaba, and then for example you will see from, let's say, Apache. Okay, you will see some MCP server from AWS, see, and Azure have their MCP server. So these are all trustworthy companies. They have hosted their MCP servers. There are many lists. You can scroll down. So alphabetically it is arranged, and then after that it comes community server. So basically here, these are the MCP server that not officially, but these are any people can build an MCP server and they can send a PR, and now that those will be listed over here. So but that only thing, like, this is not tested, and that's why these should be used at your own risk. Okay, just to give an example, if I search over Uniprot, okay, so this is an unofficial MCP server for Uniprot. So if I just click over here, so this is a GitHub repository by some guy, so this who have developed some tools. Let's say he has written a Uniprot search, so using which we can search Uniprot streaming, Uniprot entry, and Uniprot ID mapping, and Uniprot blast. So these are the some of the tools he has written, and he has hosted this server in the form of Uniprot MCP server. So basically, we no need to rewrite again. So what we can do, we can download this MCP server and we can give our agent and to connect to that MCP server, so that all this functionality our agent can now do. This is just an example. So now you can get some MCP server from, let's say, PubMed MCP server is there. But again, I'm not sure whether this is officially, since it's a part of what is that community one, so it's developed by some people. And again, in our video series, we will be building our own single cell MCP server, and we will be hosting it, and we will try to make it available over here. So that kind of things also we can is part of the series. But this gives you some idea that basically MCP server is nothing but some GitHub repository code. Basically we just pull it and we are using, the way we are pulling some Python package like NumPy, scikit. That way we will pull the MCP server code, and now we will connect our agent to that code, and now our agent will be able to talk to that MCP server, as simple as that. Okay, so now let's move to a little bit theory part to understand what is MCP. MCP is what? Model Context Protocol. So the model is the who, the context is what, and protocol is how. So basically, model means what? Who wants that information? So here the AI agent, right? So that means, let's say you are using any agent like Cloud, ChatGPT, that wants some information. So that's the who part. So model, the LLM model. The context is like what information he wants. So let's say you want to search on Uniprot, right? So basically you want information from Uniprot. So that's why you want some tools which will help you to pull that information. So the tool is the context. So what the model needs access to. So that's what the model need to accessible. So basically the model can be any database, public databases, or it can be some readme files, or it can be some API, web service, anything, So whatever the MCP server serves, those are called the context. So basically your model wants to access those context or those capabilities of that server, basically. And third is the protocol. So this is how you will pull. So now you know what to pull, right, from that MCP. So now this protocol tells that, okay, this is the protocol by which you can pull that information. Okay, so that means protocol is the connectivity part. So for example, HTTP protocol allows you to connect to an internet, right, internet protocol. So that way MCP protocol allow your agent to connect to an MCP server. So that's how the MCP is like model context protocol, the who, the what, the how. Okay, very simple. So now just to give you before why MCP came into picture, so what happened, like just to give you an example here in this example, our AI application, if you connect to a GitHub MCP server, your agent can now do all the functionality of GitHub, like sending pull request, reading the reviews, committing, those kind of thing. You can connect your agent to an, let's say, Google, or let's say Google MCP server. So you will be doing all functionality of Google Drive, Gemini, Gmail, like that. Similarly, you can connect to a local file system. You can connect your MCP to Slack or web APIs or even databases, many. So simply you have to have some server where all those functionalities are there. You have to follow the MCP protocol to connect your agent to that server. Okay, so now why this came MCP? Okay, so earlier what happened when MCP was not there, there was this problem was that called M cross N integration problem. So basically, let's say you have M model. Let's say you have a model from OpenAI, or model 2 is from, let's say, Google's Gemini, or let's say this is from Anthropic. And let's say some people have developed some code in Java, some people have developed code in Python, some have written in Node. So now you see for every model, different model and N possible integration. So you have to write your code in different possible way. Okay, so that's what the M cross N connection was there. But now what MCP did, hey, so now this changed to M cross N to M plus N integration problem. So what MCP did that, hey, if you want your tools or packages to be used by any agent, you must follow the MCP schema. So if you want to host anything, make sure that you follow the MCP schema. Same way, you are asking a client, hey agent, if you want to connect to MCP server, you must follow the MCP protocol. So both now server, the client, so these are the client who wants to use the server, and the server who wants to serve. So both the client and server both are now following the MCP protocol. So that's what they changed the game, like, from M cross N integration problem to M plus integration solution. I would say problem to solution. So now MCP plays the intermediate between the client and server kind of thing. Okay. So what does now MCP server actually serves? Okay, so I think there is a mistake over here. Server serve. So there are three components you would say. So an MCP server can host some tools. For example, I have shown you on Uniprot, right? So he has, let's say, 5 tools are there, like how to search. Like, so the tools are nothing but the Python functions or any functions where you can call that function and do some action. Also, MCP server can also host some resources. So basically, let's say Uniprot server is there, let MCP server, and you are documenting some documents, okay, about Uniprot, how to search query, how to do something, or you some can host some FAQ files about the, some FAQ files, or you can put some knowledge bases. So these are the some read only resources will be hosted. So now whenever your agent needs, he can go and refer to those resources and get the information and then call the tools, that way. And third thing is called prompts. Prompts are nothing but, let's say, predefined templates. So now see, I have written an MCP server. I know that it's not an easy for you as an user to write some prompt to connect to my MCP server, because my MCP server might be very complex. So that's what I will do. I will write some prompts, ready-made prompts, and I will make it available. So what, as an user or an agent, you will use that, you will use my prompt, so that my prompt is better suited for interacting with my tools and my resources, right? So that's why, instead of writing your own chart command, you use my prompt. So that's how the tools, resources, and prompts come. But out of this, 95% in MCP server, actually they provide tools. Only few provided resources and prompts. Very complex servers, they should provide the resources and the prompts. Okay. So now we need to understand three concepts. One is called host, the client, and the server. So host is something where as a user, like for example, you interact. For example, you are using ChatGPT. So you are a user. ChatGPT is the host. Or let's say you are using cloud desktop. So here you are a user. You are using the cloud desktop as an interface. That's the host. Okay. So now each host, when connecting to an, so now you, let's say, ask a question to the cloud desktop. Let's say, can you connect? I want to search a Uniprot protein. So now what this cloud desktop will do, host, he will now create a client. Okay, a client is nothing but your agent who wants to search MCP, search Uniprot. So now it will now connect via MCP protocol to that Uniprot MCP server, and then it will call the query. So that's why host. So host will create a client, and that client will connect to a server. Okay, now same host can have multiple clients depending on the multiple questions. So let's say you ask a question like, okay, I want to book a flight, I want to connect to Uniprot, I want let's say NGSQC. Now let's say there are three functionality I have requested, as a user. So now I have asked this question to cloud desktop. So three questions I ask: can you book a flight ticket for me? Can you search a Uniprot? And can you do an NGSQC? Now three requests. So now the cloud desktop will, because it's a host, right? Because it is now understanding user query, it will now launch three clients. One client will connect to, let's say, flight booking server. Now the second client will, let's say, connect to Uniprot MCP server, and your third client will connect to the NGSQC MCP server. So now you can understand, right? So each client will connect to always one server. So there is one-to-one relationship between client to server, but one to many. So your host can connect, spin multiple clients, and each client will connect to each server. So that's why you will see in this diagram one-to-one relationship. So for example, your client 1 can connect to local file system, your client 2 can connect to database, your client 3 can be connect to web API. Just forget about these two. Maybe cloud desktop you can put in the middle, so that we've got an idea, right? User will interact with cloud desktop, which is the host, depending on the questions. Okay, now the host will spin a client, which is nothing but AI agent, and that will connect to an given MCP server. So that's why these three terminologies you will see: host, client, server. But host, you forget, just think in a very simple term: client, server. Client is your AI agent, server is the server your agent is connecting to. Okay. So now we understood like three things. We understood what are the what MCP server serves. Now we understood how client and server connect. So now let's talk about actually how do they connect. So how do the communication happens? It's like your client is there, your server is there, so now they are talking. How will they talk? So that's where the protocol transport layer comes. So there are three terminologies you will learn, like you'll see that one is stdio and ssc and streamable http. ssc is now deprecated. It was deprecated in November 2024. So now only two protocols are there. One is stdio and the second one is streamable http. So basically using this, either of these two, stdio protocol or stdio is nothing but standard input and output, okay, and the http protocol through which you will be able to connect the client and server. So let's see. So very simple. Let's say there is MCP server hosted and you are a agent. Okay. So what it will, you ask a question. Hey, can you search in Uniper? So now whatever you did type question, that will go to the standard outputs. For example, how you are writing print hello world, right? That goes to your standard output stream, right? So whatever question you ask, that will go to the standard output stream. Now your host, the server, is able to read that from the output stream. So the standard output stream will now go to the standard input stream of the MCP server. So now through the standard input, so this is like, how you type your command line argument in Python, right? The same way MCP server now listen to the stdin. He got the input. A user is asking about unified search. He will do the search, and whatever the response he will get, he will put it the same way, print hello world, how it put into the string stdio. So server will output into the stdio stream. Now that output will go to your client. So that's why, so both this client to server communication is happening via simple stdio in and stdio out. These are the two input output stream. So that's why this is only applicable in your local system. That means in your laptop, the same system, same everything, you are able to connect your client and server. But here the protocol is different. So this, the second protocol is the HTTP protocol. So basically now you have an MCP server, let's say, that is running in some somewhere. Okay. So in this example, let's say it is running on your local laptop, maybe in local host or somewhere, or maybe it can be also deployed in any actual API server kind of thing. But let's say it is hosted somewhere, and let's say in this example our protocol on our local system, and let's say we send a request. So instead of sending stdin, now we will send a http post request, and then MCP server will send the response and we will get the response. This is how this normal HTTP post and response, request response kind of communication happens between the agent and the MCP server. Okay. So in short, so MCP server, if it is there, right? So where there are two possibility. One is, let's say, MCP server hosted on the cloud. Let's say someone has hosted some cloud. So basically you can directly connect your MCP client to that server through using that exact URL what they provide. Alternately, what you can do, whatever the GitHub code I showed, right, for the Uniprot, you download that locally, and now either you run it two-way. Either you say that, okay, you have downloaded that MCP server, now you run it either in stdio mode or you run it in HTTP mode. So it's up to you. So if you are using in stdio mode, and if you ask a question, what is 2.2, 2 plus 2, you will communicate via stdin, stdout, like this way communication. Or if you are saying that, no, I don't want to use stdin, stdiout, instead I will host it. So now whatever you downloaded, you now run it, and now your server will be available on some local host and port. And now you can directly connect via HTTP streaming mode. Okay. And third, as I said, this is where also in order to connect your agent to any remotely hosted MCP server, you will also need the HTTP streaming mode to connect. So this is how your client and MCP client and MCP server works actually. So yeah, so that's about MCP. So if I just summarize, like MCP server is nothing but, the model, the context and protocol. And when I say context is nothing but either tools, they can be the resources, or they can be the prompts. So three, MCP server exposes three such main capabilities. And now we talked about the host, the client and server. So client and server always one-to-one relationship, but a host can launch many MCP clients. And we need two protocol mainly, the stdio and the streamable HTTP protocol. In stdio, we use in and out to connect, but here we are sending post request and we getting the response from the MCP server. And the third category is the cloud one, right? So in order to use a cloud one directly, we have to communicate via HTTP protocol. But to use a MCP server, you have to download it locally and either run it via stdio or HTTP streaming mode. Okay, so that's about the MCP theory. In next, we will do the actual hands-on. So where we will move, we will download some, community MCP server, and we will connect both. We'll see two framework. One is programmatically how we will access. That's where we will be using AI SDK, and we will be using Open AI SDK agent, but you can use any other because the overall concept will be, sorry for that, very similar. And then we will talk about, see how to use the cloud desktop, uh, and we'll explore both stdio and http protocol. But before that, in the next video, will first I will demonstrate the setup guide. So we need to install something like ub, fast mcp, OpenAI Cloud Desktop, NPM, those kind of things we need. I already have given the setup instruction in my GitHub repository, so you can go to this repository. I will provide this link into the description. If you go over here, so they are organized into different phase kind of thing, and at the end you will see the setup.md. So here I have given main setup instruction like how to do it. So that's what in the next video I will talk about or walk you through. But you can, if you follow this, you can skip the next video. Okay, so yeah, I hope you like this introductory video about MCP, and yeah, so I'll see you in the next video, and stay tuned. Thank you so much for watching.